So example 3, we have the graph of the reciprocal. So this is working backwards. We have to think, what would the original graph look like? We're told right here in the question that it's going to be a line. So we have to think back of the steps that we did in the previous one. How is that going to help us find our original graph? One of the key steps that we did in our original one is we drew an asymptote where? Where did we draw our vertical asymptote? At the x-intercept. So right now we know that we're going to have that point. Now in order to graph a line, how many points do you need to graph a line? 2 points. We've already got 1. So if we can find one other point, we'll be able to graph a line. So choose anywhere on our red graph and label a point. Something that looks the easiest to label. If you look at all those points, maybe this one right here. Well, that point would be when x is 0, y would be 0.5 or 1/2. No, that's on the red graph. I graphed a point on the red graph in red, 0, 1/2. That looks like an easy point to label that has nice values. Now, if that's the reciprocal of the line, what would have been the original point on the blue line so that when you flip the y value, make it 1/2, 0, 2. Oops, that's not blue. And because it told us originally it was a line, you can see that 0, -2 would be another point. You only need 2 points, and that is the original function. That's it. Not too bad. From here to here, that's if we look at our steps from before, that was step 3. Originally, we had labeled points on our blue graph, 0, 2. And if we knew 0, 2 was on the line, then on the reciprocal, it'd just be 1/2. So whatever the y value just becomes 1 over that. So if you know what the 1 over value was, then you would know the original one had to be 2. And that is it. Question number 8.